NENOMATICA, where mathematics meets YouTube excellence. Welcome! In this lesson, we will connect the standard quadratic form to the vertex form and see why a parabola perfectly models the path of a jumper. Step 1. The standard form of a quadratic relationship is y equals ax squared plus bx plus c with a not equal to 0. This represents a parabola. The A controls opening and width, B controls horizontal placement and tilt, and C is the vertical intercept. Step 2. We convert to vertex form by completing the square carefully. First, factor from the x terms. Next, add and subtract the inside square term, b over 2a squared. Then group as a perfect square and distribute a. Finally, identify x naught as negative b over 2a and y naught as c minus b squared over 4a. This gives vertex form. Y equals a times x minus x naught squared plus y naught. Step 3. Let us see a real example. So the vertex form is y equals negative 0.5 times x minus 3 squared plus 6.5. Here is the graph with the vertex marked, the axis of symmetry, and let us animate a skier moving along the curve to the peak and back down. Step 4. The parameter A controls opening direction and width. If A is positive, the parabola opens upward. If A is negative, it opens downward. Larger absolute A makes the parabola narrower. Smaller absolute A makes it wider. Summary. A parabola is modeled by y equals ax squared plus bx plus c. Completing the square gives vertex form. Y equals a times x minus x naught squared plus y naught, where x naught equals negative b over 2a and y naught equals c minus b squared over 4a. Quick practice. Convert y equals x squared minus 4x plus 1 to vertex form and read off the vertex. Great work today. You now know how to move from standard form to vertex form, interpret the vertex, and visualize a parabola like a jumper's trajectory. Keep practicing. Interpret the vertex and visualize a parabola like a jumper's trajectory. Keep practicing. Let us state the general quadratic. Y equals ax squared plus bx plus c. Step 1. The target is vertex form. We can write y equals a times x minus x naught, all squared plus y naught. You can derive this by completing the square on ax squared plus bx plus c. Algebraically, that becomes y equals a left bracket x plus b over 2a, right bracket squared, plus c minus b squared over 4a. Step 2. Read the geometry from vertex form. The point x naught, y naught is the vertex, and the vertical line x equals x naught is the axis of symmetry. If it is positive, the parabola opens upward, and the vertex is a minimum. We will increase a to make the parabola narrower, but still opening up. Notice the vertex acts as the lowest point, a minimum. If it is negative, the parabola opens downward, and the vertex is a maximum. Let us switch a to a negative value. Now, the vertex is the highest point, a maximum. In this lesson, we will derive the maximum or minimum value of a general quadratic function. We'll follow a clean 4-step algorithm and visualize why the result makes sense. Step 1. Treat the function value like a constant and move it to form a standard quadratic in x. We write ax squared plus bx plus the quantity c minus f of x equals 0. Step 2. For real solutions, the discriminant must be greater than or equal to 0. Delta greater or equal to 0 implies b squared minus 4ac is greater or equal to 0. In our rearranged equation, c becomes c minus f of x. So b squared minus 4 times the quantity c minus f of x is greater than or equal to 0. Step 3. Distribute and isolate the term with f of x. We get b squared minus 4ac plus 4, a f of x is greater or equal to 0. Move constants to the other side to obtain 4a f of x greater or equal to 4ac minus b squared. Step 4. Divide by 4a. If it is positive, the inequality direction stays the same, and f of x is greater or equal to 4ac minus b squared over 4a. If it is negative, the inequality flips, and f of x is less or equal to 4ac minus b squared over 4a. This value is exactly the y value of the vertex. A helpful reminder. The x-coordinate of the vertex is negative b over 2a. Plugging that back into the quadratic gives the vertex y value, which matches our formula. On the left, A positive gives a cup-shaped curve. The vertex is a minimum, and the range is above the vertex value. On the right, a negative gives a cap-shaped curve. The vertex is a maximum, and the range is below the vertex value. Today we will graph the parabola y equals 2 times open parenthesis x minus 1 close parenthesis squared plus 2 by plotting points. First, let's display the equation clearly. Then, we will compute y values for a few convenient x values to sketch the curve accurately. Step 1. Calculate corresponding y values. For x equals 0, y equals 2 times open parenthesis 0 minus 1 close parenthesis squared plus 2, which equals 4. For x equals 1, y equals 2. For x equals 2, y equals 4 again. Let's place these in a small table so we can see symmetry around x equals 1. Step 2. Identify the vertex and whether the parabola opens up or down. Because the equation is in vertex form, y equals a times open parenthesis x minus h close parenthesis squared plus k. The vertex is h, k. Here, h equals 1 and k equals 2, so the vertex is 1, 2. The coefficient equals 2, which is positive, so the parabola opens upward. The vertex is a minimum. Step 3. Graph the parabola by plotting the points and sketching the curve. We will draw coordinate axes and then place the points 0, 4, 1, 2, and 2, 4. Notice how the points mirror across x equals 1, the axis of symmetry. We will now draw the smooth U-shaped curve passing through these points. Finally, we mark the vertex A at 1, 2 and indicate the minimum and axis of symmetry. Summary. We graphed y equals 2 times open parenthesis x minus 1 close parenthesis squared plus 2 by plotting points at 0, 4, 1, 2, and 2, 4, identified the vertex at 1, 2 as a minimum because it is positive, and drew the smooth upward opening curve with axis of symmetry x equals 1. Welcome! In this example, we will graph the parabola y equals negative 2x squared plus 1 using the vertex method. Step 1. Rewrite the equation in vertex form. The vertex form is y equals a times x minus h squared plus k. Here, y equals negative 2x squared plus 1 becomes y equals negative 2 times x minus 0 squared plus 1. The vertex is at h equals 0, k equals 1. Step 2. Create a small table of values around the vertex. We will evaluate x equals 0, 1, and negative 1. At x equals 0, y equals 1. At x equals 1, y equals negative 1. At x equals negative 1, y equals negative 1. Step 3. Determine the opening direction and whether the vertex is a maximum or a minimum. Since it equals negative 2, which is less than 0, the parabola opens downward, and the vertex a0, 1 is a maximum. Step 4. Plot the points and draw the curve. We place the vertex at 0, 1, and the symmetric points 1, negative 1, and negative 1, negative 1. The axis of symmetry is x equals 0. Finally, we sketch a smooth downward opening parabola through these points. Final result. The parabola y equals negative 2x squared plus 1 has vertex at 0, 1, opens downward, and is symmetric about x equals 0. Great work! Downward, and is symmetric about x equals 0. Great work! In this video, we will graph the parabola y equals x squared plus 2x plus 1. We will use the vertex method, build a short table of values for accuracy, and then sketch the curve. Step 1. Rewrite the quadratic by completing the square. We recognize a perfect square trinomial. X squared plus 2x plus 1 equals the quantity x plus 1 squared. So y equals the quantity x plus 1 squared plus 0. That tells us the vertex is at negative 1, 0, and the parabola opens upward because the coefficient of x squared is positive 1. Step 2. Make a quick table around the vertex to get accurate points. Let us choose x equals negative 3, negative 2, negative 1, 0, and 1. Compute y equals the quantity x plus 1 squared for each. Notice the symmetry around x equals negative 1. Step 3. Let us set up axes, plot the vertex at a few points, and show the axis of symmetry. The axis of symmetry is x equals negative 1. We will plot the points from the table and mark the vertex in green. Step 4. Now we sketch the curve y equals the quantity x plus 1 squared. Because the leading coefficient is positive, the parabola opens upward, and the vertex is a minimum. We will label the graph and highlight the direction of opening. In this example, we will graph the quadratic y equals x squared minus 2x minus 3. We'll follow 4 clear steps. Complete the square, build a table of values, identify the vertex and direction, and then graph the parabola. Step 1. Complete the square. We want the vertex form, which is y equals the quantity x minus h squared plus k. Starting with y equals x squared minus 2x minus 3. Add and subtract 1 inside to form a perfect square. That gives y equals the quantity x minus 1 squared minus 4. Step 2. Build a small table of values using the vertex form. We evaluate points by substituting x and computing y. Let's compute values around x equals 1 to use symmetry. Step 3. Identify the vertex and the direction of opening. Because the leading coefficient a is positive, the parabola opens upward. From y equals the quantity x minus 1 squared minus 4. The vertex is at 1, negative 4, which is a minimum. Step 4. Graph the parabola. We'll draw coordinate axes, then plot our points and the vertex. Plot points at negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, and 3, 0. Draw the axis of symmetry x equals 1 as a dashed line. Finally, draw the smooth U-shaped curve through the points. In this lesson, we will graph the parabola given by y equals x squared plus 2x minus 1 using the vertex method. We will complete the square to find the vertex, identify the axis of symmetry, pick a couple of symmetric points, and then sketch the curve. Step 1. Convert to vertex form by completing the square. Focus on the x squared plus 2x part. We add and subtract 1 inside to make a perfect square, because b over 2 quantity squared is 1. This gives y equals left parenthesis x plus 1 right parenthesis squared minus 2. From this, the vertex is at h equals negative 1, k equals negative 2. Step 2. Determine the direction and the axis of symmetry. The coefficient is 1, which is positive, so the parabola opens upward. The axis of symmetry is x equals negative 1, the vertical line through the vertex. Step 3. Pick symmetric points using the vertex form. Using y equals left parenthesis x plus 1 right parenthesis squared minus 2, evaluate at x equals negative 3, x equals negative 1, and x equals 1. We will make a small value table to organize these points. Step 4. Graph the parabola. We set up coordinate axes. Mark the vertex at negative 1, negative 2. Draw the axis of symmetry as a dashed vertical line x equals negative 1. Plot the symmetric points negative 3, 2 and 1, 2. Finally, sketch the smooth curve of y equals x squared plus 2x minus 1 through these points, opening upward. In this lesson, we will graph the parabola y equals negative x squared plus 6x minus 10. We'll convert it to vertex form by completing the square, find the vertex and axis of symmetry, make a small table of values, and then sketch the graph. Step 1. Convert to vertex form. Start with y equals negative x squared plus 6x minus 10. First, factor out the negative sign from the x terms. Now complete the square inside the parentheses. Half of 6 is 3, 3 squared is 9. Add and subtract 9 inside the bracket, so we don't change the value. The trinomial becomes x minus 3 quantity squared. Distribute the outer negative and simplify. Our vertex form is y equals negative x minus 3 squared minus 1. From vertex form, y equals a times x minus h squared plus k. We have it equals negative 1, h equals 3, and k equals negative 1. So the vertex is 3, negative 1. The axis of symmetry is x equals 3, and because it is negative, the parabola opens downward, making the vertex a maximum point. Next, let's build a quick table of values close to the axis x equals 3, using the vertex form y equals negative x minus 3 squared minus 1. 4x equals 2, y equals negative 2. 4x equals 3, y equals negative 1. 4x equals 4, y equals negative 2. These points show symmetry about the line x equals 3. Now, let's plot the parabola and the key features. The vertex is at 3, -1. We will also plot the points 2, -2 and 4, -2. Draw the axis of symmetry x equals 3 as a dashed line. Finally, sketch the curve y equals negative x minus 3 squared minus 1. Notice the symmetry and the downward opening, confirming the vertex is a maximum. In this example, we will graph the function y equals x squared plus 4x by completing the square and by point plotting. Then we will find the vertex, the axis of symmetry, and key intercepts. Step 1. Completing the square. We take half of the coefficient of x, which is 2, square it to get 4, and we add and subtract that 4. Now, group the perfect square trinomial. Finally, factor and write the vertex form. Y equals open parenthesis x plus 2 close parenthesis squared minus 4. Now we place the points -4, 0, -2, -4, and 0, 0. Next, we sketch the parabola using the vertex form. This lowest point is the vertex at -2, -4, because the coefficient of x squared is positive. The vertical axis of symmetry is x equals -2. Finally, notice the x-intercepts at -4 and at 0. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.